Hi, I'm Kuba, and today we'll create a fantasy shop adventure assistant with Rust and Gemma large language model. Today's goal is to build an assistant for heroes who need to choose an appropriate weapons for their adventures. For example, a hero's team wants to confront a mighty dragon, so the advice for them will include a dragon-slaying weapon of legend, elixir of giants, and other essentials. To develop our RAG solution, we'll go through several steps: collecting and preparing a dataset, calculating embeddings, choosing an appropriate vector database, and finally, using an open-source large language model to build an assistant. Our dataset will be in Delta Lake format. To read it, we'll use two Python packages that are built with Rust under the hood. Polars, which is a blazing fast data frame package, and delta-rs, which simplifies reading delta tables without Spark. To read a delta table, we can simply use the readDelta method. Our delta contains two columns, scenario and advice. We'll create an additional context column called combined, which is simply a concatenation of the scenario and advice columns. Now it's time to calculate embeddings, which are multidimensional vectors calculated, for example, from text. To do this, we'll use the E5 small model together with the Candle library. Now it's time to write some code in Rust. We'll use the Candle transformers library to create an E5 model struct and add two methods. First, we'll download the model from Hugging Face, and second, we'll calculate embeddings for provided texts. We would like to use Rust code in Python. Thus, we'll use the additional PyIO3 packages. In our case, we'll wrap our Rust code with the Python Adventures module and Adventures class. After compilation, we are ready to import our Adventures module and calculate embeddings for our contexts. Now it's time to choose a vector database where we'll store our embeddings. To do this, we'll use the lancedb database. We can simply use the Python API to create a fantasy vectors table and create an index for it. Visible warnings are caused by the too small dataset for our advices. Now we can confirm that we are able to use the created index to search for the most appropriate context. For example, in the first step, we calculate embeddings for adventures with a dragon text, then we search for the most appropriate context. It's time for the large language model. In our case, we'll use the Google Gemma model. Currently, Gemma models are published in two sizes, 2 billion and 7 billion parameters. Additionally, we can use the instruct model type, which offers a specific turns prompt format. We'll use the Rust Candle project to create a Gemma model struct and load method implementation. We aim to improve the user experience, and instead of creating a simple request-response method, we'll use an additional async stream Rust library to stream text generated by the model. Now we are ready to create a fantasy shop assistant. Suppose our heroes team comes to the shop and wants to prepare for an adventure with a dragon. Let's take a quick look at our solution architecture. We have already collected the data, calculated embeddings, and indexed them into the lancedb database. Now it's time to create a microservice that will expose a chat post method, where our heroes team will send prompts. Inside the microservice, we'll calculate embeddings using E5 model, then search for the most appropriate context, build a large language model prompt in instruct format, and finally stream generated responses for the Gemma model to the heroes. To build the microservice, we'll use the Actix Web Framework. During application start, we'll load the Gemma model, E5 model, and additionally, we'll create a lancedb table object. For the Gemma model, we need to provide our Hugging Face token, which confirms that we have accepted the Gemma model license. Inside the chat post method for request prompts, we'll find the context, which will cover calculating embeddings using the E5 model and searching for the most appropriate context. Now we are ready to build an instruct prompt using a simple template. Finally, we'll pass the instruct prompt to the Gemma model and stream results. In this case, we run the Gemma model on the CPU. Let's check how it performs. The response is really nice, but let's try to improve our solution performance. To do this, we'll use a model quantization process which reduces model weight's precision. In the next step, we'll use another open source large language model, Mistral, with 7 billion parameters which use 4-bit quantization. We'll use the Candle library to load the model in gguf format, but in this case, we'll use CUDA to run it on a GPU card. Now we are ready to test our assistant with the new model on the GPU. The solution performance is much better and the assistant response also really nice. Our heroes team is ready for the adventure. You can find the solution source code on my GitHub. That's all for today. Don't forget to smash the like button, subscribe to the channel, and hit the notification bell to stay updated. Thanks for watching. Bye.